I really strongly hope that I do not have to say this, but I'm still going to. Disclaimer, making hydrochloric acid at home is extremely dangerous, even for trained professionals. The reason I did it is, well, because I wanted to, and I literally had to ask the Austrian government for permission to do this. Well, not that they responded, but I'm still gonna do it. To be honest, making hydrochloric acid at home is pretty dumb. Well, I did it, but that doesn't mean you should. So, let's get into it. Well, I have sectioned the video into 4 chapters. First, I'll go over the introduction, which is this part. Then, I will go over how I will make the hydrochloric acid, what is the general idea. Then after that, I will be producing the hydrochloric acid, and then, least but not last, are my final thoughts on this. Here are all of these sections with the timestamps, so you can jump if you really want to. Let's get into it. So, the idea behind all of this is electrolysis with salt water. Why? Because when you do electrolysis, basically running electricity through water, then chlorine gas and hydrogen gas, well, get created. Then I can get the hydrogen and chlorine gas to react with each other, forming hydrochloric acid, formula HCl. Yeah, the process is simple. I don't know if I'm gonna be able to build it. Here's a more precise planning of how I'm gonna do it. So, the thing on the right here is a one-way valve, which only lets airflow in one direction, which is really useful. On the jar here, I have got salt water in it, and 2 one-way valves. One of them is pointing inwards and one of them is pointing outwards, so basically the air can flow through. The reason they're there is I'm gonna pump air through one, and then the air which is in there, the chlorine and hydrogen gas, which are gonna get produced in the electrolysis, are gonna get pumped through into the bottle through the other one-way valve. Then that minuscule thing that is on the side of the bottle, this is an UV LED. The reason I use an ultraviolet LED is because it makes the chlorine and hydrogen gases react, which is, well, useful because on their own the gases are pretty useless, or at least that's not how I'm gonna use them. Then, as soon as the gases have reacted in there, they will get pumped through the water. And now, basically, this is then where the hydrochloric acid should be. Now, you may ask, where are the electrodes? Because of laziness, I didn't want to draw them. So I started by drilling the holes where the one-way valves would then go. There they are. I then looked if the one-way valves fit, and they fit really great. Because I was going to be using a plastic bottle, I was heating the cap of it so I could put the hose through, which only proved semi-working because it didn't quite work the first time, neither did it the second time, but the third time's the charm, they say. To be honest, that does kind of look like a condom. Dang, why is this so hard? I just can't seem to get it quite right. Because after the first 2 bottles broke, the third one luckily went pretty well. What did I just do? How am I gonna... I'm so dumb. Wait. I hope I have enough time to... Yes? Yes? Yeah. Oh, it's hot. Well, unsurprisingly. Look at that. Would you look at that? You know, that's okay. This isn't even that bad. Coke, you did not disappoint. Well, kind of, but, you know. I think we can work with that. Now I'll just glue it on. The question is how? Oh, probably hot glue. So how I did it now was this. I put hot glue in the inside of the cap, then I screwed it on. I'm really surprised I could actually do that because, you know, the hot glue wasn't actually in the way, so I actually could fully screw it on. Yeah, I really didn't think that through before doing it, but I did do it, and I'm not complaining because it works pretty well. And then I put some hot glue on my finger and on the seal between the pipe and the cap. Now this is not fully hard yet, but it will be hard later. Wait. Oh, then I drilled a hole into the bottle to be able to fit the one-way valve. Which went, I mean, okay, the hole wasn't perfectly straight, but you know, it worked out fine at the end. So now I have made this hole a little bit bigger, and let's just try inserting the, oh yes, oh that size works pretty well. Now I will have to seal that too, but I'm right now thinking about if I should do this with silicone or with hot glue again. I ended up making it with the hot glue. Now before putting the bottle on there, I'll just add the electrodes. Now how I will continue with the electrodes like this, I will first drill 2 holes on each side. They will be pretty close together, and then put some tin wire in there. The reason I use tin and not copper is because tin isn't really reactive. Yeah, that isn't very true. When you use copper for electrolysis, something happens like in this video. Watch that, definitely, it's really interesting. Now that's it. By the way, fun fact about copper hydroxide. Did you know the first chemical that was just pure that I ever produced was actually copper hydroxide? And I made a video about it. Watch it! So, let's drill. I folded the tin wire a few times until it looked like this. Then because the higher the surface of the wire, the better, I hammered it with a hammer after heating it with a lighter. And this is a quick before and after. Admitted that was the most epic transition you've ever seen. To be honest, that was quite trash. But anyway, here's how I did it. As I've already told you, I just hit it with a lighter for like a few seconds. And then I hit it with that really big hammer. Now I used tin wires, but that is a problem since chlorine attacks tin. I thought this through good, but turns out I didn't. But lucky for me, I have these carbon fiber rods at home, which I will now use instead of the tin. So what I also had to do is re-glue the plastic bottle because it didn't really hold well. And now it's all pretty much airtight. I tested it. And now the thing is, I'm gonna call the Austrian government tomorrow to ask for permission. Like right now, I do not have permission. Why did I build it? Because, you know, I didn't want to wait, I guess, and, you know, why not? So I will inform you tomorrow on if it will, if I'm allowed to do it. You know, basically, if you're saying this, I probably got a permit to do so. Yeah, turns out I forgot. Now, I've got this UV light from a friend, thanks by the way, and I saw that this little piece of together, like look at these two contacts, they are so close together, and I have extremely shaky hands. This was a pain to produce. This was a pain to produce, yes. So with everything done now, basically the experiment is able to So basically with every part now made, we are done to do the experiment. But that doesn't make any sense too. Anyway, let's do the experiment. So it is all set up now. Here is the power supply and, you know, everything that I've shown you, and a few, you know, kind of trash, useless things. And the reason they're there is just so the heights are optimal. Now let's turn this on. So for my voltage I've chosen 10 volts, now let's turn it on. Okay, we are ready. Now let's connect the 2 electrodes and see what happens. Come on. Thank you. Okay, let's get you into a better perspective. So the electrolysis has started, and now I have to start pumping, which is important. Okay, 10 volts was maybe pretty high because the hot glue literally melted on the electrodes. I figure I will just put it on 6 volts for now. Let's see what happens. So I know on the screen you can kind of see the screen refreshing, which may be annoying. I'm sorry for that. Now let's turn it on. Okay, it's still producing gas. Hey, wait, why is this so... Anyway, now I have to start pumping. Oh! So stupid. I literally forgot to add the UV light. So, here it is, the UV light. The thing is, you cannot see the UV actually shine because, well, one, we as humans cannot see UV lights, and two, well, you could actually on a phone camera, but it's too bright outside to actually, like, notice. I continued on doing this for half an hour or so, and this happened. Look at this photo. You can see the water in the jar is yellow and not the liquid which the hydrochloric acid should be produced in. Now, this just tells me that the setup isn't ideal, not that it's bad, per se. Why? Because the liquid is yellow, it tells me that some chlorine has reacted with the water. But it doesn't say that chlorine hasn't gone over into the water it should go in. Now, because hydrochloric acid itself is colorless and pretty see-through. Now, I will do this for another hour or so. So I got back to setting up everything again, and something weird happened. Turns out there wasn't actually any air bubbling out of the container where it should have been. Oh my god, oh, I'm sorry you have to see that, I'm so sorry. What the What the hell? When I pump through the air, it doesn't like go out there, it just goes like nowhere. Wait, let me fix you real quickly. Wait. Okay, now I will pump on 1, 2, 0. Oh, wait, sorry, the wire's in the way. Get out the way. Yes. Now. What the hell? This is not... it's leaking somewhere, but like badly. For there to be like 0 air coming through where I want it to. That's not good. Look, I can push... What the... I'm at the verge of getting very angry right now. Yeah, so I took the jar off, and what the hell is this? This kind of looks like the thing that was in my beer. What the hell? I do not understand. Wait, let me touch this with a test tube. Oops. What the hell is this? Oh, is this hot glue? I can imagine it's hot glue. But... Ugh, why did I touch that? Okay, I guess it's kind of fragile. I should wash my hands. I think it's actually super glue. Yeah, turns out the whole setup just decided to break. Now, the thing is, I have, luckily, these pH test thingies at home, I guess, and I'm gonna test them on 3 things. 1, the container where the hydrochloric acid should have been. 2, the jar, and 3, normal tap water with some salt in it to, like, simulate what it would have been if there were no hydrochloric acid, which there probably isn't. Lucky for me, the pH test thing is also to pick up on chlorine, which is kind of useful. So it's the next day and let's check on the results. The reason I didn't check yesterday is because the sun went down fairly quickly after I put in the pH test things, and when it's dark I can't like check it. Or I can, but it isn't great. Now let's check. Okay, I just went outside and why does this look so weird? What is that? Oh, it's ice! Oh. Now, how do I check? Can I get this out, please? Oh, this water is really cold. Get out! Oops. Yeah, okay, the thing is, this one is for the pH. Let's see. Well, can't really see much. But this one is for the chlorine and it showed almost no results. Yesterday I saw some little results in chlorine, but like, yeah, not much. Now let's check this. I don't want to touch it. Wait, let's check this one first, and then ugh, this is like a slushy. Ew. Wait, what? I find it interesting that the salt water has more chlorine than the water where the chlorine should have been. Now let me put on gloves really quickly. So let me take it out. Okay, this looks like actually it has a low pH or something. This scale does not go very low, sadly, but I can see some amount of chlorine in there. So yeah, I mean the experiment proved kind of successful, I guess. Okay, this one is for the boys. Yeah, overall I would say that this experiment was only semi-successful, but I have a good idea on what I will use the apparatus in a future video. And let me tell you something, it has to do something with something fairly explosive. Oh yes, I look very forward to that. Thanks for watching the whole video. Bye.